Okay, so continuing on here, we're going to look at how do we determine if we're still in the cut or not. When we looked at the output, see we've got a couple of these last lines here. Cut pause 2 equals 3 and C end equals 3. And cut pause 2 equals 4, C end equals 0. So we know cut pause 2 is in the cut pause 3 and cut pause 4 are at the end. And C end of 3 or C end of 2, so if we go back in here and turn on the entry and exit, and then we post this out, and here same thing, you can see cut pause 2 equals 3, C end equals 1, cut pause 2 equals 4, cut pause 2 equals 4, and C end equals 2. And that's happening in the line and arc section. So you can see this is all, arc, line, line, and then we hit our rapid. So really this is where we want to potentially output our coolant off code. So let's go and set some logic to do that. PeelInOut and pxcoolcheck are really where we want to try and capture this stuff. I'll set a bookmark here. We'll go up to our general output settings. We just need a variable here. So vector constants, feed rate, variable, MISC variables. This is probably a great place to add it. And okay, we're going to call this a flag variable. And generally a flag variable is just a variable that we're using to indicate the state of something. So when we turn something on, we set this variable to 1 or to 2 or to 3 to indicate the state. And that's what generally we're doing with a flag variable. It's just another numeric variable, but we're using it to indicate the state of a particular function. So it starts out as 0, and what we're going to do is go to PeelInOut, and we're going to say if cut pause 2. So let me adjust my lighting here a little bit. Okay. So what I'm doing here is I'm testing cut pause 2 and CN. So if cut pause 2 is greater than 2 and CN is any non-zero value, so CN could be 1, could be 2, could be 3, doesn't matter, we're setting retract cool flag to 1. And I'm going to add this line of code at the beginning of pxcoolcheck as well. Now, when we do something like this, we also have to know where to reset these values. So we're setting retract cool flag equal to 1. Now, when this has been turned on, we know that we want to make a call to our pretract cool post block, because that's what's going to shut the coolant off. So if we go to our WrapItOut, so I've added this code in pxcoolcheck, and I've added it in PeelInOut. And now up here, we say if retract cool flag equals 1, now we also want to see if coolant has been turned on. And in order for us to see if coolant has been turned on, we have a variable for that. It's called CoolingOn. Because CoolingOn is going to hold that binary sum. So if CoolingOn So, if retract cool flag equals 1 and coolant on, in other words, there's something to turn off. We are going to end up calling pretract cool. That's what's going to turn off our coolant code for us. And the other thing that we're going to do here is say retract cool flag equals 0. So we're going to reset the flag value after we turn off the coolant. And this bit of code right here, if retract cool flag equals 1 and coolant on, then we're going to call the pretract cool post block and we're going to set our flag equal to 0. I'd really like to be able to call this on my output line. But in order for me to do that, I don't just want to paste all this code into the middle of my output block here. So what we're going to do we're going to create our new post block, pxcoolcheck. And I'm going to put all of this code right inside pxcoolcheck. So if retract cool flag equals on, equals 1, and CoolingOn, we're going to execute that code there. And now what I'll do is in pWrapItOut, we have scooling, and I'm going to add the call to pxcoolcheck at the end there. And what this should do for me So what that did for me was to output the M09 on my retract line here. As you can see though, it turned my coolant off, it moved positions, it turned my coolant on. So this code isn't exactly ideal. Yeah, it functions, but really we'd like the coolant to remain on here in between operation 2 and 3, but we were successful in turning the coolant off here, which is nice. So we were able to move the coolant up to the last retract line. We'd still have to do some more work to suppress the coolant off in between here. Now we can check something. We go back in the post here. Here's our debug for our rapid. The next variables are what we can use to kind of search ahead. The next op, next OP, contains the next NCI G code. So we'll debug current G code and next op to see if that gives us any useful info. Okay, so let's look at this output. And if we look at our rapid line, unfortunately, it doesn't give us anything super useful, because it tells us that the next NCI G code that we're going to encounter is the 1011 line, which is just the miscellaneous real numbers. And all that means is that we have another operation coming up. Unfortunately, we don't know whether that next op coming up is NCI G code 1000, which is a null tool change, or whether it is NCIG code 1002, which would be an actual tool change. Now there's still maybe something else that we can check. P tool change 1002 and P tool end can sometimes be used to flag stuff for us. So this should get called at the end of every toolpath. And we could potentially use the check of op ID not equal to last op ID here to flag new operations coming up. So one of the things that makes this difficult for us to be able to tell where we're at inside the code is this. If I repost these with some depth cuts and some multipasses, here's the tool change. And here you can see there's a move right here to Z0, turns off the coolant, rapids up to 0.2. You notice that we do get a call to P tool end. But what we're doing here is simply moving over position and cutting again. So this code right here is a multipass. This code right here is also a multipass. So the problem becomes, how do we differentiate between where one op starts and another one ends? So we can do some testing in P tool debug, much like we do in P tool change 1002, to see if the op ID has changed. But in general, you want to try and stick with the existing structure of how they turn stuff on and turn stuff off. And one of the things you'll see if you look in the MP master post, if we go to the null tool change post plot, you can see that there's actually quite a bit of pretty complex logic to determine if something has been turned on and needs to be turned off, if the tool plane has changed, or if something was turned on and now it's turned off, or it was turned on and now the value is still on, but the values are different. So maybe we changed our high-speed mode from roughing to finishing. That's what this code does for us here. And again, it's pretty complex to be able to check all of these conditions. And what it does is to shut off these modes, force a retract, put out the MO, or call pretract 0. And you'll notice that we set this flag variable called retract flag equals 1. Then we do all of our normal kind of next op stuff. And at the end of the toolpath, so all of that stuff happens. And at the end of the toolpath, or not even at the toolpath, at the end of the null tool change post block, we have some code that checks to see if the retract flag was turned on. And if the retract flag was turned on, remember that happened up here. If it was turned on, then we basically reapproach by calling out all these values again. So we, turn on, you can actually see if retract flag goes all the way to here. So basically we move to the work offset location in X and Y, we turn on the spindle, we output our HSM codes either before or after the tool length based on what type of high-speed code it is. And if retract flag was not turned on, we execute the else condition, which is basically approach the part without turning on, the work offset and the XY position. Just basically just move to the position because tool length was never canceled. And that's what this code kind of right here does. So being able to check and track all of these modes is much better done inside MP Master versus the generic Fanuc posts from CNC Software. So that's why I used this post as a sample for the class to describe the logic that already exists inside here and give you some examples of how to manipulate it. So we are rapidly approaching the end of class. I did want to open it up for questions a little bit. So let's just take a quick poll and see if there are questions that anybody wants to ask. Go ahead and type them in, and we'll see how many of them we can answer before we wrap up our class. No questions, guys? I mean, if not, that's fine, but, this is your time. Don't get me wrong. I mean, if we're done, we're done, and I'm happy to wrap it up, man. Oh, you're on mobile. That makes it tough. You want me to unmute you, Nick, so you can ask questions in person? Okay, fair enough. Yeah, no problem, man. Like I said, this is your guys' time to ask questions. So, all right. Well, I think we're gonna wrap up class, guys. Unless there's anybody else who wants to, ask a question or contribute. Yeah. All right. Well, thanks, guys. You know what? We're gonna go ahead and wrap it up, and I will wish you guys a very good evening and good rest of the month and year and all that stuff. Yeah, no worries, John. I totally get it. I understand. There's a lot to go through, and this is just the beginning. So, gentlemen, it was a pleasure. So, thanks, guys. Oh, Nick, I did want to say, so far I've only got like 2 people signed up for the course. So, just giving you a heads up. We may postpone that to September. Unfortunately, there's just I've put out the notices, and we've kind of gone through the rounds of contacting everybody, and it seems like everybody's on vacation, kind of for the month of August. Good. Okay, good. I like hearing that. If that will work out better for you, I'm just going to go ahead and do that. We're going to postpone to September, and that way, normally we try to have at least 10 people to run the class. Any less than that, and it's I'm taking away time from my wife, a lot of time actually, and it's just I already have a full-time job, so at the end of the day, I come home and it's like, oh, I got to do the training. I like doing training, believe me, I do, but yeah, it's got to pencil out financially too for me to justify it, especially my wife. So, all right, gentlemen, it's been a great pleasure.